Hi everyone and welcome back for our new tutorial video. Today, we will cover Linux memory analysis using Dump It for Linux and Stardust. First, let's create a fresh Ubuntu virtual machine for our tutorial. Most of our virtual machines running on the cloud, either Microsoft Azure, Google Cloud Platform, or Amazon AWS, are Linux-based virtual machines. Even though Linux is more popular, there is a significant gap when it comes to the available security tooling on Linux. Incident response on Linux is significantly behind compared to Windows. Memory analysis is becoming significantly more important on Linux due to the overwhelming presence of containers, especially in Kubernetes clusters. Let's continue by updating the app repository and installing the latest version of Docker to be able to run the free containerized version of Dump It for Linux. Running Dump It for Linux via Docker is straightforward and leverages the Comae Python CLI available on GitHub. The option allows the user to archive the memory dump directly to a Google Cloud Storage, Azure Storage, or AWS S3 account. But the coolest features involve the interaction with Comae Stardust for automated analysis. You can either send a full memory dump to Stardust, or, as we will see now, you can pre-process the live memory and send only the metadata to Stardust in a very short period of time. When using the SnapIt parameter, we need to provide the Comae Stardust credentials available to the user interface of the platform. The same credentials also apply to the Dump It parameter, which will create an ELF core full memory dump to be sent. The nice thing about the snapshot mode is that it creates an archive which only contains the collected metadata derived from analyzing the memory. This has several innovative benefits such as performance. As you can see now, it is very fast to pre-process the image locally and takes less than a minute. This means that it opens multiple scenarios such as scalability, which is critical if you're planning to look at Kubernetes clusters. Imagine a scenario where a Kubernetes hook will be triggered each time a container gets destroyed. Pretty cool, right? Full support for analysis includes Ubuntu, CentOS, and Red Hat, and we are currently expanding the support to Google Container Optimized OS and Amazon Linux. Once the image is loaded and analyzed, we can browse the processes and drivers. Just like Windows, we have several detection playbooks to automate the analysis, which can be summarized in the report view. We would love to hear your feedback on how you're planning to use memory analysis for Linux and about your current pain points. Our solution does not require any pre-profiling of the machines, which also has been for long a big pain point on Linux with performance. Just like Windows, the visualization features such as the tree view are also available. And since the container is running as privileged, we can see all the Docker and their children processes launched. Thanks for listening. We hope you enjoyed this tutorial. Your feedback is more than welcome, and do not forget to subscribe to our channel.